All right, we'll get started in a couple minutes. Okay. All right. Well, we have a small group today. Adam, Chad, Adrian, Justin.
How's it going?
Good. How are you guys doing?
Good.
Doing pretty good. I have David here. All right. So, how do you all feel about SQL? So, like, give me a thumbs up, thumbs down on the comment in the channel. That's kind of how I'll get the feedback. So give me like, okay. So SQL, just put it in there. So give me like thumbs up, thumbs down, or I don't know, or some kind of emoji representing how you feel about it.
To a message or okay.
Yeah, on the message. Yeah, so just go put like a little emoji on it if it's like no mouth. All right. Meh. Okay, great. All right, so SQL is really one of the most, honestly, is like one of the most transferable and one of the most important skills really that you learn on the back end. It's used in a lot of different jobs. There's a lot of position like there's a lot of even non-programming jobs that require it. I mean, it's really just broadly applicable, broadly useful. We used to teach Mongo. So we used to teach MongoDB. That's what we started at. And basically, MongoDB, the way that it stores the information, it stores it as like as like a JavaScript object, basically, kind of like a JSON object. It's not really JSON; it's called BSON, but it's yeah, basically like an object. Um, so so MongoDB, you have this, big object of key value pairs. And anyway, that's just how you store the data. And it's pretty natural learning MongoDB from a JavaScript background, especially if you're doing Node. So you're just always kind of in the JavaScript world. But the majority of companies out there use SQL, a relational database. So we call it a relational database. A relational database is basically, you can just think of it as like, rows on a spreadsheet. Yeah, so pretty much all, or like most companies generally are using this. And so there's a couple different flavors, but they overlap quite a bit. So you have, let's see, okay. So you have, like Postgres is what we use at Lambda School. That's one of the more popular ones. You have MySQL. You have like the Oracle databases. SQL Server. There's a bunch of different flavors of it, and companies will all use different variations, but they're all like 90% the same. And so there's a pretty heavy overlap between all the different relational databases. So if you learn one of them, you then like those skills and everything transfer over very, very easily to the other languages. And so a lot of the trickiness, honestly, with the relational databases comes with how we communicate with them in Node. So Node as a backend language is still relatively new, and it's growing, and there's more and more companies using it, but it's not the most widely used, backend language. Java is probably the most widely used one, but that's kind of going down a little. There's C#, some of those other ones, and so but the underlying relational database that we're interacting with, it's these same principles, and you're going to be using SQL. So SQL, SQL. You'll hear it said both ways. SQL is the language we use to interact with the relational database, and you're going to use SQL regardless of what language you're using on the server. So if you're using Node, you're still going to be using SQL or those concepts, and it might be this kind of bastardized version of it that they've made from using whatever query builder or tool that they have, but it's still like SQL at the heart of it. And and that's going to be the same regardless of whether or not like you go on and learn, if you go and learn Java, or if you go and learn C# or another one, like you'll find that communicating with the database, those principles are going to be pretty similar and almost identical across backends. So it's very transferable. This is one of the most valuable skills you can be picking up. I wish I knew it better. In my previous job, it was all like MongoDB. We were, a very JavaScript heavy shop. Going along, we actually wish we weren't MongoDB. There were some different, scalability issues and things that Mongo kind of blew up on us. So relational databases can be faster and can be more scalable if you do it right and handle it right. So, but again, it's something where you could spend your entire career just getting into database land. So we're like talking about just like the very basics here, and this is something that you could go and spend the next 20 years, really digging into this. So, it's a pretty big field. So, okay. So we have our relational databases, and there's a couple different kinds. So that we could be working with, so MySQL, Postgres, whatever. We're going to be working with Sqlite. Sqlite is just really easy to get going with. This is the one that's in your that's in all the Learn programming documentation stuff on on learn.lambdaschool.com. So, and the reason we use it is it's just very, very easy, to get going. So basically with SQL, well, okay, so typically, the way it works is you have your client, that could be a browser or a mobile phone or whatever, and they are going to communicate over the internet. So they send an HTTP request to a DNS server. So a DNS server is what does the mapping between like the name google.com and the actual static IP address that like is like the address that the computers use to find a location. But google.com is a lot easier to remember than a bunch of numbers separated by periods. So so the request goes to the DNS server. The DNS server gives your computer an IP address to communicate to, and then the client then goes and communicates with your server that's at some static IP address, and then this server can communicate with a database server, and that database server is the one that's actually going to be reading and writing to a hard drive. So you get kind of this big chain going along. So with SQLite, we actually don't really need to have the server running. It gets handled by so we're just going to write our server. We're not going to have like a separate we're not going to have like two servers running on our computer. Like I think it may get spun up in the background behind the scenes, but we don't have to manually go and set up like a SQLite server. Whereas if we were doing MySQL or something like that, we actually would have like in two tabs in your terminal, you would have like your Node server running in one, and then you'd have your MySQL server running in the other tab. So you actually would have two servers talking to each other. And so, and if you had your Create React app going for the client server, you'd potentially have three servers. So you'd have like your server serving up your React content, which will talk to your server, like your API server, then the API server will talk to your database server. So you get all these computers that are all talking to each other. And so anyway, it's helpful to keep that clean and organized and understand like what that ecosystem looks like. So and so the idea is that the database server is the one that's is the one that's going to handle the like reading and write operations to the hard disk, the hard drive. So, but we don't actually have that in SQLite. In SQLite, you're gonna have a file It's going to act like your database, just in your folder, and your API is going to reach out and talk to it. So most likely when you go to a job, and if you're using a relational database, you're probably not going to be using SQLite. You're probably going to be using Postgres or MySQL, or like the Oracle one. Like those are like the most commonly used relational databases. And in that case, will be working with the server. And but there's just so many different flavors of it, and they're all like 90% the same. We're just gonna focus on SQLite because this is like the easiest, fastest way for us to get up and get like playing around with SQL and playing around with the database. So anyway, so that's what we're gonna work through today. We're gonna write a file that's going to, or basically we're gonna see how to set up the SQLite database, and then we're gonna write a script that we're just gonna run over and over again, and we'll use that to interact with the database. And then I'll show you how you can actually set up like a little shell, a little kind of like a little server that they can actually go in and you can manually like run queries against the database, and you can interact with it through the command line. So you don't actually have to be like running a full script. But anyway, so that's what we're going to go through. We're just going to walk through that. We're going to go over the basic CRUD operations. Can anyone tell me what CRUD means? What that stands for?
Create, retrieve, update, destroy.
Yeah. Create, read, update, delete. Yeah, basically like that. Yeah. Just those are kind of like the basic. So like a lot of tutorials you'll see with like backend languages and databases, things like that. They try to cover those 4 distinct pieces, because once you can do those 4 things, like you can pretty much solve any task that you need to solve, like your API needs to solve. So we're going to walk through. I'm going to show you how to create, how to add rows, how to create a table, how to add rows to a table, read, how we can retrieve that data, how we can update, how we can delete it. And then if we have time, maybe I can spin it up into like an Express API. We can play around with that. Okay. All right. So let's, all right, so let's get started. Okay, so I have an empty folder. First thing I'm gonna do is I'm just gonna go npm init. It's gonna, I don't care about what any of this really says right now. But basically I just wanted to create generate the package.json file. And you could manually create it, but I'll just do init, and that sets it up faster. And then now what we're going to do is we're going to install a couple packages that we're going to be using. So we're just going to be doing everything in plain SQLite today. I know a lot of the stuff you did used Connects, but we're just going to keep it in plain SQLite just to keep it very light and focus specifically on the database, how it's being set up, how to like read and write to it, and those interactions. And then later you can add connects onto that, and connects makes it easier to do more complicated CRUD operations. But for right now, we're just going to keep this simple, and yeah, anyway, we'll play around with it. So all right, so now I'm going to let's see, just 1 second. On my notes. Okay, so I'm going to install, actually SQLite3 is the only dependency that I'm going to be using right now. So npm i-save SQLite3. So that's going to drop it into this folder. That's going to add a node modules folder and a package lock.json, which helps us track the version of all the different libraries. So as your program gets bigger and bigger, an issue that you have to worry about is the versioning of the different packages. And so like we bring in SQLite3, and then a year later, there's going to be a new version of SQLite3. Maybe 3 or 4 new versions have been released over that time. And so then maybe there's things that start to break, and you get these weird issues. And so the package lock JSON, part of that is it helps us track the version of all of the directories, like the node module. So anyway, that actually becomes like a big deal, like a big project to like upgrade your application to work with like the new version of some library, or upgrading it to work with the new version of Node. So, okay, so we have our node modules folder, all that was created. We just added a single package. And then I'm going to create our script file, so touch index.js. So I'm just, so just creating just a blank JavaScript file. That's the one that's going to go in and query against our database. And then now I'm going to create a database file which is just going to be empty. So I'm just going to go touch example.db. So, and I can put it in its own folder, but I'm really just trying to keep this like as simple as possible and not get messy at all with like the the file structure. So right here we have just the database file. We have this empty script file I created. We have the node modules folder, which was automatically generated. That has the Sqlite3 stuff in it. We have this package.json that was automatically generated, and we have our package.json, which is like the recipe automatically generated. Okay. All right. So the index.js file is the only one we're actually going to be writing any code in. So, all right. So inside of here, so the first thing we need to do is we need to figure out how to interact with the database. So like, how do we, it's okay. So like, how do we connect and how do we do all that? So first thing we got to do is we need to import our Sqlite3 library. And we're going to do verbose. So we're calling this verbose method on it. What that's doing is it just means that the logging and the messages that get printed out are going to have more detail to them. And so it will help us debug a little bit better. So while we're learning, this is what we'd want to use. In production, you may have a different logging tool or something that you'd be using to track your logs. But for right now, we're just going to use verbose, and we'll get more detail there, messages and things. So help us figure out what's going wrong a little bit easier. Okay, that's the only thing we have to import. That's our only module. And then now we're going to set up the database. So we're going to do const db, and this is going to be an object. And we're going to use the new keyword here, Sqlite3. And then we call this database method on it. Okay, so the database method, we can do things, it has like you can do something like this where it creates a database in memory and it doesn't actually write it to anything. This can be useful for like playing around and experimenting with things because it just keeps it in memory. When the script closes or whatever, the database gets cleared up. And so you don't have to be worrying about like cleaning out data or things like that, like stuff that's getting saved, because nothing's getting actually saved to the hard drive. So for playing around, that can be nice. I want to actually connect to a file though, so you can see how that flow goes. So what we're going to do is I'm going to type in the path to that file that I made. So it's example.db. But then because it's a path and we're specifying a file that we're going after, we're going to use this / in front of it. So just like with require, when we're requiring a module that we've created and not one that's in the node modules folder, we have to put the / in front of it. So it's the same thing here. So this DB object that we have created here, when we do this, this is going to open a connection to the database. And this object is basically like the API we're going to use to interact with that database file. So the DB object, it's a JavaScript object. Like this, literally, like the Sqlite3 library creates a JavaScript object that has a bunch of methods on it, and we can use those methods to read and write to the file. And it's a lot easier to do that than like, it's like we could do this all in vanilla JavaScript without Sqlite3. Like we could, use the file sync API and all that weird node stuff that you've probably seen when you've been Googling things on Stack Overflow. So like we could do that and just like manually interact with the file. The Sqlite3 makes it a lot easier. And so it's just a bunch of helper JavaScript functions built around it that allow us to interact with the file in like a secure way. Makes it less likely that we'll have bugs and things like that.
Question.
Yes.
What's the no keyword for? Is that just something required by SQLite?
Yeah, so that's just part of their project, part of their API and the way they developed it. Sorry, I'll be back in just sorry about that. Yeah, so the new keyword right here is basically, you know, if you remember back to like when you're using classes, like ES6 classes or constructor functions, that must be how they've written it. So they've written this like the dot database, like right here. They're using a capital D too, which implies that it's a class. So it's, you know, we could actually even, you know, something like this actually might even read a little bit better. What we can do is, so we can do something like that, and then, okay. So basically we're pulling database off of the SQLite, and then we're using the new keyword with the class. And so basically like we're creating a new database object in memory. And then off of that database object, we can then use that to communicate and, you know, with the database, which is just that file, which all databases basically are just files. It's just files on a computer. And then like we use, you know, a language or tools and things like that to communicate them with in like a safe, structured way that minimizes errors and bugs. So it's just databases are just files on computers. So in this one, the file happens to be in the same directory. Usually it's not. Usually it's, you know, in a separate computer, a separate server, whatever. But anyway, so we're doing that right here. Okay, so we have our new database object. So an optional parameter we can pass in here is we can give it a callback function. It's just a callback error function, arrow function, and an error first callback. Basically inside of here, I can just say if error, let's see, return console log error. I'm putting the return there just because I don't want it to keep executing. I don't want the callback to keep executing if there's an error. And then down here, I'll say console.log. Let's see, database connection established. Okay. So this is just like messaging there, helping me to control if there's an error and be able to see that. Yeah, so that opens it up. That opens up our connection, establishes it. So we're gonna open it up, and then we're also gonna close it down at the end. So we're gonna do the same thing down here. Just db.close, that closes the connection. Yeah, and so basically whenever we're gonna interact with the database, we'll create the database object, we'll, you know, run some queries against it, and then we'll close the connection at the very end when we're done. So just like when the server's gonna close down or whatever, we'll close it up. So, okay. So the same thing here with the close, we can give it an optional callback function to give us some additional information if there's an error. So if error, return console log error, otherwise console log. So I know that like I'm never gonna hit this line right here if there's an error, and I'll never hit this line if there's an error. So if I see both of those messages printing out in the console, that means it successfully opened the connection and successfully closed without producing any errors. So these callbacks right here, these are called error first callbacks, which means that there's an error as the first parameter in the function. This is extremely common in Node, where the first argument given to a callback function is an error object. So then the top of your function code is going to be doing something related to the error, checking to see if there's an error there. Yeah. So any questions about this? Any questions about callback functions? Give me.
I do have a question about, so like this Connects is doing this behind the scenes. It's always like connecting to the database and disconnecting. That's always how SQL databases work.
Yeah, so there always needs to be a connection that's either opened up. Yeah, so there's always, so any database that you're working with, you're going to be opening a connection to the database at the beginning, like at the start when your server is going to start up, you know, on startup. Yeah, so that's like with like Mongo, like you're going to have like, I think it's going to connect to the server, and so and up in here you're going to put like, or if this was my SQL right here, this would be like a URL, you know, that's going to like reach out and connect to us. So like if it was running on our computer, it would be something like, you know, localhost port, whatever, you know, 8080 or something would be the database port. And then, so then we'd connect to it on that port, or you'd be connecting to it over the internet. So if it was like on AWS, you would put like the AWS, you know, like the database server connection URL there, along with like a username and a password that you'd be sending along. We don't have to specify a username and a password here because it's just this file in the same directory. But if the database was running, you know, over the internet on a different API, you'd have to like send along credentials and things like that. Okay, so again, a callback function is just a function we give to another function, gets invoked behind the scenes. This is something that you need to be just extremely comfortable with. You know, if you're not familiar with the idea of callback functions, if this idea, like if you're still not 100% on it, like this is absolutely something you need to spend a lot of time reviewing, because callback functions are used all the time. Basically everything with functions, like recursion gets asked about in interviews and then you'll never use it on the job. Like recursion, like is hardly ever actually used in practice, like occasionally, but very, very rare. But other than that, like closure, callbacks, just, you know, like all the different, like, you know, like higher order functions and all those different types of patterns as it relates are extremely important to know, and one of the most important JavaScript like concepts that like you need to understand. So definitely spend some time doing that. Spend some time doing like map and like map, reduce, filter, for each. Those are also extremely important. So spend some time doing that too. Okay, isn't one of the limitations of Sqlite3 is that you can't have multiple connections? I'm actually not sure. Sure, to be honest, that might be the case. I know that Sqlite3 isn't used in like it's not used a lot in production. Usually, yeah, I'm not sure. Yeah, I'm not sure exactly. I have to look into that. Okay. All right. So let's go and all right. So we opened up the connection. We closed it. Let's do some stuff with it now. So we're going to use this method on here called serialize. And basically what this is going to do is this is going to make it so all of the database commands that we're going to issue, it's going to ensure that they happen in order. So because these read-write operations can be done asynchronously, I'm pretty sure that the writing to the file here is done asynchronously. If we were communicating with another server, it absolutely would be asynchronous. And so with asynchronous connections, you can get this like, it's the idea of like a race condition where, or just like it's, when we're communicating with another API, we can't be certain the order that the messages will be processed. So like we have our client here, and well, let's actually make it specific to like the data, like our server. So here's our server, and it's gonna communicate with the database server. You know, so this is our database server. This is the API. Just our application server, and then this is our actual database. So sorry. Okay, so basically this database server, so if we're kicking off all these requests, you know, so kick off a request, another request, another request, you know, so 1, 2, 3, we can't be confident that they're going to be processed in order. So maybe there was some hiccup on the network and request number 2 actually gets there before request number 1, or maybe with the database, maybe it's like being multi-threaded. We don't know how it's processing them. Maybe like the first request is going to take 5 minutes to run and the second request takes 10 seconds to run. And so the database server is processing them in parallel, and it actually does, finish number 2 before number 1 and sends that back. Basically, like it creates this issue where whenever we're communicating, over a network, we can't be certain the order that it's going to be processed. And so that's where tools like async await come in, or just like there's a library called Bluebird that used to be really popular. Async await kind of stole its thunder a bit. I think async await is a better pattern and flow to work through, and I'll talk about that in a bit. But so the SQLite here has this method built in called serialize, and what it does is it helps us. Basically, it makes it so all the database commands that we're going to run inside of it, it's going to ensure that like command number 2 is not going to be run until command number 1 finishes, and then command number 3 won't run until command 2 finishes. And when I write the code, you may think like, well, the code obviously should complete in that order. But if I took all the commands out of the DB serialize, they actually wouldn't be guaranteed to run in that order, and so it can create issues where, in our logic, maybe we run these 2 or 3 commands, and then the 4th command relies on the first 3 being finished, but then if you get this weird race condition where the 4th command is actually running before the 3rd one finishes or something like that, and then it creates a bug and error. But then we only have the error some of the time, so as we're trying to test it and figure out what's going wrong, it's like half the time it works, half the time it doesn't, and we can't figure out what's changing it. So it can get really nasty. Bugs can get really nasty when you're working like over a network. So anyway, db.serialize is basically just helping us like run these all in sequence. Just how like your normal JavaScript code is going to run like on your file on your computer. Okay, all right, so let's go in. Serialize takes a callback function, and inside of it, we can write all of our commands. So this is where we're going to walk through some of the different CRUD commands and just go over some of the basics of SQL. So all right, so here inside of it, first one we're going to do is we're going to create a table. So the database object has a run method on it, and the run method basically follows the syntax of like we can do our SQL here, and then we have some like parameters that we can pass in there, and then a callback function. And so that's the basic flow for the run command, and we're going to be using this one a lot. So with the run command, we actually don't get the output. So if we're wanting to query and retrieve stuff from the database, we don't use run. But if we're just doing like updates or creating tables or things like that, or deletes, we'll use the run command. If we want to like retrieve something to send back to the client, we're going to use like a different method. And they have a couple. You can do like all. It's like db.all, db.each, db.get. We're just going to use get, but each and all are very similar. They're just for like working with larger sets of data, and very similar to actually like some of the array methods that we have, like for each. But anyway, we'll get into that in a minute. So basically, yes, these 3 commands. And so another reason why I wanted this to plain SQLite here is so we can just practice writing just the plain SQL like queries without it being like abstracted away by something like connects or things like that. And so it's actually kind of nice to just integrate directly like this, because we can get that practice with plain SQL, which is very transferable. If you're comfortable with basic SQL, you can write it anywhere. So all right, so this first one, we're going to create a table. So I'm going to do create table, we call it users. I'm going to give it username, text, and password of text, just to keep it simple.
And sorry to interrupt, would you mind bumping up the font just a little bit?
Yeah, they're pretty small. Okay, is that helpful?
Yes, thank you.
I can actually see it better too now. Okay, all right, so yeah, so this is how we're going to create it. We actually don't, so I'm not entering any option like other parameters, so I'm going to get rid of that. I'm not going to do a callback there. Well, yeah, I'm not going to do a callback. I'm going to write some other queries so we can like test it. Actually, I know how we'll test it to see if this works. So what we'll do here is, okay, so if I run this script right now, so nothing is making this a server right now. This is just it's a script, meaning that it will have a start, it'll have a finish, and it'll be done. It's not going to sit and listen. And so if I run this script, okay, so I'm going to do node, and then I'm going to run index.js. Let me see it. All right, so database connection established, database connection closed. Okay, so now it's like, how do we tell if it worked or not? So I could put a console log in there and kind of see. I mean, we didn't see any errors appear. You know, there may have been one that we didn't catch. You know, so maybe I should have had the callback in. Anyway, but there's a little, you know, uncertainty here. Like, how do we inspect the database? How do we look and see what's actually going on? So there's a tool that you can install. It's npm-i-g Sqlite3. So basically, it's a Sqlite3 package. You can install it at the global level. So remember, when you use the -g flag, and installs the npm module for the whole computer, not just the folder. And so that's when like you install Node1 or other tools like that that you can use for your whole machine. I've already installed it, so I'm not going to run it again. But what I can now do is I can say Sqlite3, and then I can say example.db. I type in this command, and it opens up this like little shell where I can interact with the database. So yeah. So for example, so let's see if I do help. You can see here. Anyway, there's a whole bunch of different commands and stuff you can do, but I'm gonna do schema, I think. Okay, yeah. So I do schema. Let me see here. This is the instructions that were used to create the table. So you can see here that we have the users table. The users table was entered. It's in there, and so there's a lot of other commands here. You know, we can do to to interact with it. Yeah, so here's so let's do this one like for tables. So tables, and so we see we have a users table. So that's how we can check to see if it's created. And so anyway, this is a nice way to get in and inspect, and we can actually run SQL queries against it. And I'll show you how we can do that in just a minute. But so I'm going to leave this open. I'm going to jump back over into the other tab, and I'm going to open a third tab that I can use to run actually run the node commands to run the script. So okay, all right, so that works. So now what I'm going to do is I'm going to show you how to drop a table. So because okay, so if I run this file again, just leave it how it is. If I run it again, so you get this error. So SQLite error, table users already exists. Okay, so I can either modify this command, or I can be deleting the table. So for the sake of the script, I'm actually going to show you how to drop a table. But we can also do we can also modify this to say create the table if it doesn't exist. Also, what'll often happen is you'll be using a database design tool, or has a user interface or something like that, or you'll be running your script to set up the database initially. And then when you start up your API, your server, it's not going to actually be running these table creation commands. You're just going to kind of do that once at the beginning to get it all set up, and then future times your server runs, it's not going to actually you're not actually going to go in and create the tables, because you have a full database that you're going to be interacting with. But just for right now, just to kind of show you how these different commands work. Anyway, that's why I'm taking this approach. So, all right, so we created it, but then what we're going to do is we're going to run basically just a drop command. We're going to drop the table. So drop table if exists, and then users. Okay. All right, so if the users table exists, we'll drop it. The reason the if exists thing is in there is that if I did something to clear it out and I ran the script, it would fail. If I say drop table users and the users table doesn't exist, there will be an error and the whole thing will fail. But so I'm going to put that if exists thing in there. So anyway, so now let's go and run our node script again. So establish closed. Okay, great. So it worked. And if I come back in here, you see users is created again, but it was a fresh one. It was created. Okay, so now each time we run the script, we're going to delete the table if it exists, and then we'll create a new one from scratch. So again, just so we can play around with these CRUD operations. Okay. All right, so now, all right, so we've gone through creating a table, dropping a table. Let's add a record to it. Okay, so what we're going to do is we're going to say db.run, and then we'll have our command. And this one, we're actually going to have some parameters. And actually, I'm going to leave off that callback. And I'm going to show you a kind of a cool trick you can do here. So what we're going to do is I'm going to put a try catch block around this, which is actually something you would use with like async and await. So basically, what's going to happen here is if any of these produce an error, it's going to print that out. Anyway, and actually, I might want to experiment with that later. I'm pretty sure this is going to do what I want it to do. But then this will make it, I believe this is going to make it so I don't have to go in and put those like callbacks in to check for errors each time. I may need to go double check, but something to play around with though is this idea of like a try catch, this try catch thing. Basically in the try block, it runs some code. If there's an error, we can handle the error in a custom way. Here. Okay. All right, so to create a record, we're going to do, so insert is what we're going to call it. So instead of, so there's create table, but we're going to do insert here. So I'm going to say insert into users, and I'm going to specify which columns I'm going to be providing data for. Because there may be maybe a whole bunch of columns, and there may be some that are optional that I'm not providing data for. Anyway, this allows me to specify which ones I'm targeting there. And then let's see, no, I'm missing something. Values, yes, okay. So then the values that we're gonna put in here. So you could also do like string interpolation, like where you're using like the $ and the brackets. So you could do something like that to build a string out, or you can do the way that SQLite kind of builds it out. So basically, with these parameters here, in order, it's going to take whatever value I pass in, and it's going to replace the question marks it finds with whatever is in the array. So I'll put the username here. I'll say Ben for my name, and then password. There's our password. And so what's going to happen is SQLite, what it's going to do is it's building this query. It's going to help us build it out. It's going to take insert into users and then the values. So again, this right here, everything here is this is just plain SQL. Like everything right here is just plain like SQL. Like there's nothing like tricky going on there. The tricky thing is where we're doing these question marks. And so it's going to read the array that has the parameters in it. And it's going to take the first thing, whatever it is in here, the first thing in the array, and it's going to swap out the first question mark for that thing. This allows us to like where we could build out an array and use a bunch of methods on it or things like that. And we could just like stick, the array name here. Anyway, that's why it's this way. This looks a little verbose right now, but can actually like save you code and save you time later. Okay, so then what we'll do here is we'll actually, I'm going to leave that.
Question about that.
Yeah.
If you had an array that you were passing in that had, I don't know, 25 things in it, would you have to put 25 question marks in there, or how do you handle the number that's in the array?
Yeah. So there may be some like ways you can kind of shorten that out. So like something that you may do is like so in that case, something you may do is like if it's like if you're if your values is something like so something like that. So if you have a bunch of commands, Sorry, 1 second.
Yeah, sure.
Okay, so what we can do here, so you can see that we have like 4, but imagine that, maybe there's, maybe there's, I don't know, whatever, there's 25 or something like that. So you have these different values. Something you could do here is you could say like, const, SQL statement or whatever you want to call it. You could build it out like more manually. So like insert into users, however many it is. I may not have matched it up exactly, but then you could do some like values, and then inside of here, you could do something like reducing it. So you could, like, if you had a whole bunch, there may be some other shortcut ways too. This is just like throwing plain JavaScript at it. But so there may be like some other like specific shortcut ways within SQLite for handling that. But you could also do like, values dot reduce. Voice is cracking. So you could do something like values dot reduce here, where you're like concatenating it all as a string. Actually, you probably don't need to use reduce there. I'd play around with it, but you probably just do like or join, I guess. Yeah, I guess. I think if I do this dot join, let me just here's something you may not know exists. If I do node, paste that in. So you can see here that produced a comma separated list like that, like a string. So it produced a string that was comma separated. And so this is actually exactly how you'd want it to appear inside of the values parentheses. So so then you could just do like values.join like that to insert it in. And then you would just say like, for here, for all of this, you would just put like the SQL statement variable.
Okay.
So this might be overcomplicating it a little, but let me, just to show you, you can do this a different way. Let me, let me just, all right. So I'm going to change this. So, so users, I'm going to say username, password, and okay. All right. So I think that will do it. And so then now down in here, I'm going to say SQL statement. Okay. So then I'm just running it. So it's like I built the string out a little more manually. And then I'm able to take the array and just kind of plop it in there and join it all together. Does that make sense what I did? Am I losing people, or is that? I know I'm going kind of fast, and so it should be review, but so I'm going a little quicker. But I know that everybody has different things that they're missing on. So please ask questions. If like for the sake of time, I am going a little faster, but don't feel bad if you're lost on this. Like please ask more questions, and and we'll take time to help. So really, like, don't feel bad if you're totally lost or whatever. One of the best things you can do is just like working through those prep assignments and the Lambda curriculum, just like working through those over again. It's like a great way to get back up to speed on a lot of this. Okay, so let's run this and see if this actually works. So I'm gonna kill this that node REPL right there. All right, okay. So what we'll do is I'm gonna run it, and then I'm gonna run a SQL query in here to see if the user's table, if it actually updated. So we'll run this, and oop, we got an error. Okay, no such column ban. Oops. Okay, so I made a column. Let's see, no such column ben. Let me look at that error message again. Okay, so 100 error event, SQL error, no such column ben, emitted error event net. Okay, so think so I'm doing the column Ben, which we have values right here. Let's see, did I write that statement correct? Insert into, and then we have values. Let's see, let me, maybe I need a space. Let's try that. Let's just call him Ben. Okay, yeah, maybe it's not gonna work out. Let me copy this code and go throw this into a node REPL thing right here. All right. Insert into users, values. That's right. Maybe I have my values part. Let me go look at this real quick. I'm just going to Google. Google is your friend. So I think I could search here. So I just want to make sure that I have my syntax right. So let's do SQL insert into a statement. Look at that. Okay. Insert into table name. I don't have a space there, but I don't think that that'll break it because I have some other code that it works with that. Let's see. Yeah, not entirely sure why that's breaking. So we're gonna do, I'm just gonna go back and revert back to the other more standard syntax real quick. Let's just see if that fixes it, and then I can go back and compare. Let's do insert into users, username, password, and then values, and then let's do okay with that. All right, so now in here, let's do then okay, and then is that our callback? We have our error, which shouldn't need that actually. Okay, all right. Okay, let's go try this. Yeah. All right, okay, so that open and closed, and tables is there. I'm gonna do select star from users. So grabbing every record out of the users table. And I need a semicolon at the end of it. Okay, so that did correctly insert. I'm not sure why, I'd have to look into it. I'm not entirely sure why that that didn't work because that isn't like interpolating it in. Anyway, so maybe something funny that Sqlite's doing. But that's, anyway, something I'd have to play around with. But we'll just leave it like this. That's something that is a little out of the scope of what I want to do right now. But that's something I would go in and investigate and figure out because you would want to have a more efficient way of doing that record creation on larger records. You know, if there's like, I don't know, 10 or 15 different things on it. Okay, so all right, so we got that insertion going. Let's do an update. So let's say we want to change the password now. So what we'll do here is we'll say update users set password, and then again, here's the question mark, which this is where it's going to like plug the things in at. Okay, so password question mark where, and I'll use username to target the record. Usually you'd be querying off of like some type of unique ID or something like that. It's usually like maybe an email. You know, username is something that you would assume is unique. You would need to set it up that way to be unique, but anyway. is new password. So that'll be a new password, and then the username is Ben. So I gotta make sure that matches. Okay. All right, so there's our update. So again, plugging that in. So set password, where username. Okay, that's pretty good. So let's go run this, and I'll go query my database again, see if it updated. Okay, open and closed. So now let's select star from users. We run it, and we see Ben and new password. So the password was quickly saved. Never, never, never store plain text passwords. Can someone tell me why we don't store plain text passwords, like in reality? Bonus points if you can tell me what we should store it as.
I mean, plain text passwords are just easy to, I mean, if you have bad security or even if you have good security, it's just too easy to get the plain text passwords out of the database.
Yeah, exactly. So if your database is ever compromised and they get all of the passwords, then a hacker can go in and imitate that a user's, as the user on the platform. The users are probably reusing passwords, so it may compromise their other accounts if they can go access, get a control of their email account or something, then they can take over everything. So we don't store them as plain text. We hash them. We use bcrypt. So we hash them and we salt them to break rainbow tables. Anyway, that's a whole other big discussion. But yes, bcrypt is a library that we would use to hash these and encrypt these. Okay. All right, so there's our update. Okay, so we've done create. Here's our create right here. We have the U. So let's make the read. So we'll show how we would retrieve the data. So like someone signing in, we need to retrieve their user record to make the do the comparison against. So we'll do is we'll say db.get, give it another command. So we'll say select star from users. I'm not going to pass any parameters in. We could do something like select star from users, where username, something like that. We could do, I don't know, it's going to do the same thing because there's only one item in the database, but I'll just write that out so you can see something that's a little more complex. And then instead of here, what we'll do is we're going to have error, and we'll ignore the error. I mean, well, the try-catch block should catch that, but anyway. All right, so let's handle that. But then what we'll do is we're going to print out this keyword is how we reference what is actually what's actually no, I'm sorry. That's I think it's an update actually use the Screwed. That's what I was thinking of. So what we're doing here is after the error, we're going to get the actual row, or it's going to give us the item that we're retrieving as the second argument. So so come in here and get the row. So we'll print that out. Yeah. So again, select star from users where username is equal to Ben, and then we have our error and row. So if there's an error, we log it out. Otherwise, we print out the row. Okay. So this right here is the read operation. Okay. All right, so let's go in and let's go run that code and we get it. Oops. Okay. All right. So, all right, when we see this big gobbledygooky thing here, who could tell me what this is that I have highlighted? What is this called? Talked a bit about it the last time we met, but I'm not sure how like the people are here today. Yeah, stack trace. Yep. So this is a stack trace. This is a printout of the call stack. So again, if you think about it, if you remember back to some of your CS stuff, every function you call opens up a new frame on the call stack. And these were all the functions that were open at the time the program crashed. And so the top level one is usually the one that your code is running in. So usually you only care about the one on the top, maybe the one below it, because maybe those two functions, top two or three functions are in the file that you're in. And everything below it is just in like the runner code that's running everything else. So you don't need to worry about like pretty much all of that. I mean, well, okay, so let's actually, if we go in, this one actually has a couple helpful things. Like you can look and see here, like inside of the serialized function that we wrote that starts on 14.8, inside of that, we have a database.get method that we called. And inside of the db.get method on line 16, column 7, we have a reference error. And this console, whatever, is not defined. So this one's pretty pretty easy to interpret, what's going on wrong here, but it's helpful to not get really scared of the stack trace. So it's just all the functions that are open starting in, from top down in descending order. You usually just totally ignore the ones on the bottom. You only really care about maybe the top 2 or 3. The computer is extremely literal with its error messages. And so anyway, sometimes it's not the most helpful, but this one's pretty straightforward. So console, I have a typo. So we go back in, typo doesn't tell us, console is not defined. Line 16, column 7, right here. Okay, and the syntax highlighting should have tipped me off to that. So I'll run this file. Okay, all right, we see here, let's clear it out and run it again. All right, so see here, this is the record that was retrieved and we printed out. So it's a JavaScript object. So the row in the database was turned into a JavaScript object. We printed that out. Okay. All right, so read. So create, read, update. So now let's delete. So db.run, and then inside of it, we're going to say delete from users where username that. Okay, so just like delete from, and then we say the table where a lot of this is just like, this isn't going to sink in until you build an API using a relational database and you're having to like remember how to do these CRUD operations. So like that's really like the most important thing you can do is just like build an API and say I'm going to use SQL and I'm going to use SQLite, and that's going to be those are going to be the tools that I use. And if you can do that, that's when these commands and everything are going to start to really sink in. Otherwise it just takes a long time and it may not really sink in. So, all right. So we'll do
I have
that.
a question.
Yes.
Are these APIs typically written like this, or is another library similar to Connects but maybe more specific to the like database type?
They're usually with SQL, because all of those relational databases use SQL. They usually have an option to be able to just manually write your SQL queries against the database. So pretty much all of them, like in every language or whatever, has like a very bare bones option for you to do that. And a lot of people actually recommend that. Like, there's some people that say like, use an ORM or use a query builder or something like Connects, and that simplifies it. There's another group of another camp that says never use anything like that because you're getting away from the plain SQL. And by using the plain SQL queries, it's actually going to be more powerful, and it's a more like universally understood like language for interacting with the database. There's kind of two schools of thought on it. In the projects I'm working on now, I'm keeping it very bare bones so I can get better at SQL, because I've always been in Mongoland and I'm trying to level up with SQL as well. So Yeah, so you usually have an option for doing that, but then there's like a whole bunch of other tools and libraries for like, like with connects, for example, like if we compare what we're doing to like a connects.js query, so if we go and look at, yeah, I don't know, let's see here, like a select, so now when it's like connects.select ID from, users, whatever, so you actually kind of build it out in a very JavaScripty way, like this right here, like this dot sum, dot from dot group by dot as, like that as, like, so this is very JavaScripty, and it is accomplishing essentially the same thing, but it's just not written in the vanilla. And so there's just like, there's a bunch of different ways of doing it. So this, again, the Connects is just like a lightweight query builder, but then you also have like larger like ORMs, like object relational mapping, which basically like ties your JavaScript objects into the tables, and they're a little more feature full. But then the way you're writing your like your database interactions, it's actually getting pretty far away from just like what this like the kind of that pure SQL looks like, which could be good or bad. So again, like, it just kind of depends on what you're looking for. Yeah, so like at Lambda School, I was talking with one of the directors of engineering, and so Lambda School uses a lightweight ORM that's built on top of Sqlize. So there's Sqlite, which is the database, and then you have Sqlize, which is an ORM. And so Lambda School, we use kind of a lightweight ORM that works with Sqlize. And anyway, to work with Postgres. So Postgres is our database, which is a relational database. So again, a lot of those tools all kind of accomplish the same thing. Every company is using a slightly different variation, but learning SQL, if you know SQL, and then like some way of like interacting with the database, like then you can pick up like anything else pretty quick. Yeah, like in a week, like if you know, like you get the other ones down pretty fast. So, all right, so let's test and see if the delete worked. Okay, so all right, so script ran, everything looks okay. Let's do select star from users, and we didn't get anything back. So the table was cleared out, but the table still exists, but it's just empty. There's nothing in it. So something I could do too is let's do actually let's do I'm just going to create another record in here. I'll create 3 of them. Okay, so we're gonna run this again. Okay, so that creates it. All right, so now what we'll do is query off of it, and we see bend2 and bend3 exist, but the first bend was successfully deleted. Yeah, so with these basic commands right here, like you could actually get pretty far in whatever, like any application you're building. Like honestly, just like with these, like as and as you build out new features into your application, and you'll start to like make slightly more complex queries, and gradually get more complex updates and things like that. But really, like this is a lot of it. This gets you halfway there, just like even with some of these basic commands. So I'll drop this code into the channel so you can take a look at it. Actually, let me put my little. Our CRUD is out of order, but anyway, it's all in there. Ah, shoot, that got weird. Oh my gosh, okay. All right. Okay, just doing it like that. All right, any last questions before we end? No, geez, that copied my entire. Okay, 1 second. Oh, I didn't even realize that it had grabbed all that other stuff. Oh, funny. Okay. All right, so there's that. Okay, so will we continue SQL next week? If so, can we see how to build a second table, foreign key to first table? Yeah, that would be good to get into some of the more advanced stuff. Yeah, get beyond just like CRUD operations. Yeah, we can cover that. What are some other things that everyone would like a review on? So I can do some more advanced SQL stuff. I know we've done a poll like 2 weeks ago, but a lot happens in 2 weeks. So let me know what other topics you would like to see me go over, and I'll do that early next week. All right, so joins, okay. All right, so foreign keys, joins. Let me go ahead and throw this in there. Next Tuesday. Okay, anything else? Just like type it in Slack if there's anything else that you'd like me to cover. I mean, I'll come up with other things to go over as well, but just like let me know, like, you know, what else you're thinking about. Give you guys a second to think about it.
Well, I'll just go ahead and tell you, since it might kind of get lengthy here, but
Sure, yeah.
typically what I end up running into the most trouble is with Postgres. A lot of times, especially if you're working in a group, a lot of people, there's always 1 to 2 to 3 people that are having trouble getting something set up.
Okay, so maybe like how to like
troubleshoot environmental problems with Postgres. Why is it where you're working on mine when it's not working on yours? That kind of thing.
Sure. Yeah.
Any tips or tricks or what to look for? Also, like configuration files, I always kind of struggle with that stuff too. They're just not terribly strong with Linux commands and all that.
Sure. Yeah, some of that DevOps stuff. Okay, cool.
Yeah, that'd be awesome.
Great. Okay, well, thanks everyone, and have a great weekend, and I will see you all next week.